Hi everyone, my name is Darek Grala and I'm a software engineer at Lyft Level 5 working on data infrastructure for self-driving cars. Thanks to AWS folks for having us here. I'm very excited for this talk. At Lyft, we follow a two-pillar strategy to self-driving. We have Lyft Level 5, which is our own self-driving division where we build software, hardware, and operations for autonomous cars. We also have a second pillar, which is open platform, where we let leading, well-vetted third-party providers on our platform. For example, Aptiv here in Las Vegas. So if you open up your Lyft app, you sign up for AV rides, and you request a ride from some hotel to another hotel. If there's an AV car available and your route is within its limits, you might be able to be matched with an Aptiv car. Now, going back to Lyft Level 5, we started in 2017. We have over 400 engineers now. Our headquarters are in Palo Alto, but we also have offices in Munich, London, and San Francisco. Now, in Palo Alto, we live a little bit in the future. We have a pilot program for our employees where they can take a self-driving cars around our office using their Lyft app. Now, in this talk, I'll cover how we use S3 at Lyft Level 5, as we have teams who operate large-scale production workloads, and at the same time, we have other teams who are more in a research mode. They operate smaller workloads, they need to iterate fast, and only select ideas get productionized. I'll talk about how we tackled scalability challenges that we have faced. I'll talk a little bit about using random keys for your prefixes in S3 and using folder-like structure for convenience. And as you might have already noticed, there will be a lot of emphasis on prefixes because prefixes determine performance. So as our cars come back from missions, we take a data disk out of the car and we put it into our upload hardware. Now we use then Direct Connect to upload it to S3, and we then consume SQS notifications in our cloud jobs to process the data, extract some metadata. We save that metadata to DynamoDB, and then we propagate it to Elasticsearch. Now, Elasticsearch is great because it lets us query very flexibly by any field or time range. This is what we started with in 2017. Our S3 folder structure was very flat. All the data was in one bucket. Keys were pretty random. So we would take MD5 of file contents, compute it, and use it as the file name. So as you can see, files that are next to each other can come from very different dates or cars. Now, this is great for scalability because everything is pretty random. The prefixes are rather random. So all the partitions that get created scale well for our workload. So we've been using this until this year. For 2 years, pretty much with no issues. Now, the challenges that we faced recently, 3 challenges. First one was backfills. For us, backfills means ingesting months or years of data within a very short period of time, hours or days. At one time, we scaled up all the way to 8,000 workers to process months of data, and then we hit different errors. We went and investigated, and it turned out that DynamoDB was starting to throttle us. So we increased read capacity units, write capacity units, and then that was resolved. So the next limit that was S3 limits. And that was a surprise to us because up until that point, we've never had any issues with S3. Now, that said, it was small enough that we just scaled down a little bit, and we were able to continue our backfill process. Second challenge that we faced was when we enable data retention. So in our metadata stores, we can only store data for maybe 6 or 12 months. And that's for various reasons. Once data is not in the index, it's very hard to locate the S3 data that we need. So we had teams that used data that was over a year old. And for them to recover it, they had to basically list through the whole bucket and then post-filter, picking select keys. Now that still ended up with small data gaps as they made small mistakes. Now the third thing that we faced was Elasticsearch scalability. We started seeing issues when we had 10 billion documents in our Elasticsearch cluster. And then as we kept going, it went to 15 billion documents, 20 billion documents, and is now at over 25 billion documents. At 20 billion documents, the situation got so bad that we started working with AWS Elasticsearch team to figure out any kind of improvements we could make. So we did make some progress. We optimized some queries, and that worked to some extent. But what we realized is that to make Elasticsearch scale would require a significant investment on our side, and it would never be truly horizontally scalable. So in parallel, we worked with AWS S3 team to make sure to see what kind of solution we can come up with just on how we store data. And we came up with this single solution that solves all the three problems that we faced. So it turns out that people, when they search for data, they usually look for a specific car, time range, or sensor, or a set of sensors. So we put all of those in the prefix. So we put date, we put car ID, and we put sensor ID in the prefix. And then we put minutes in the beginning to leverage S3 partitioning to its full extent. So the most important takeaway that I want you to take back from this is how important it is to have a static, high cardinality prefix. And let me explain what I mean by that. For example, we chose minutes. Minutes are good because people are as likely to access data from minute 7 as they are from minute 28. So we leverage all partitions. As our data grows and usage grows, S3 will scale up automatically for us. Having cardinality of 60 different minutes will be enough to have, I don't envision us having even 60 partitions for a very long time. Now, the third aspect of this is that the prefix is fairly static. So the partitions that were created based on yesterday's data will work for tomorrow's data. If we created 10 partitions yesterday, they will work just as well tomorrow. With that, I'll hand it over to Giacomo, who joins us from Lyft Level 5 London.
Thank you. So hello, everyone. I'm Giacomo from London. And in London, we're doing more of a research approach to things. And what we actually do there is we build large maps, 3D maps of the world. As you can see, this is San Francisco. And what we do is we collect a lot of images. Then we take all these images and we build a large map. And then we use this map to localize cars in these maps. And localizing cars gives us trajectories. And then we use these trajectories to understand how other people drive. There's an example still in the San Francisco area. Now, given that our system changes pretty frequently, we had to adapt actually to how we use S3. What we do is we collect a lot of data, different times of the day, different areas, different seasons, and we aggregate all this data in one map. All the input data lives in one bucket. You can imagine billions of keys in this one bucket. And we have our computer vision pipeline, which runs on AWS Batch, which ingests all this data and then produces a final map again on S3. Now, our research team wants to use S3 as if it was a file system, right? It's easy, it's convenient. And this brought us to having some very bad prefix, which is not exactly what I'm showing you right here, but you can imagine it's something like this. And this gives us then poor performance in our AWS batch CV pipeline. So we had two possible approaches: change completely our structure on S3 or try to squeeze out whatever performance we could get from S3. So we decided to first try to squeeze out all the bits from it. And to do this, we used parallel calls whenever possible. This brings you pretty easily to the maximum throughput you can get. But when you start to do this, you will see that you will have some retries necessary because things start to fail. Either you get throttled or S3 itself gives you some 500 errors. And then one important thing we noticed, it's pretty bad to list buckets which contain a lot of keys. So if you have a certain prefix with billions of keys, it's not a good idea to list that, especially in the case that you just need maybe a few specific keys. So what we did there as a first solution was just to try to chunk the list of keys into smaller lists where we knew they had a common prefix, store a file with all the keys on S3, and whenever you need some specific key, you would download this file, locally go through the file, and pick the keys you need and just download those. And that makes a big difference. And finally, one more important thing. From the beginning, we had actually an abstraction between our code and S3 itself. And this allowed us to test also other storage solutions, EFS, FSX, and in general, this is very helpful and flexible. So with these changes, let's say, we achieved a scale where we could process billions of keys. We had 100,000 calls running on batch, hitting S3. And we had long computations, 1.5 days on average, with millions of requests. And we started to see also 500 errors at this scale. So this still didn't really, wasn't enough. So we had still our research team who wanted to keep the same structure, but our maps were getting bigger and bigger. So we had to address some of the performance. So the idea there was to insert between our keys, which were not in a perfect format, in actually S3, an additional layer where we would have a two-way hash function. You can imagine it something like a scrambling function, which though you can reverse. And this allows you to have on one side keys where you can use them as if it was a file system, but on the other side, S3 will keep scaling, as you saw before, because it will have random prefixes and all these nice things. And with this, I would like to make you think a little bit before you start to use S3 in the sense, it might be that in your case, you really need more of a file system-like approach. And this doesn't mean that you will have horrible performance. I mean, hopefully it will be good enough for whatever you need. And having completely random keys, it's amazing, but you will need some kind of index or something like that. So I think it's important to think on which part of the scale do you want to be when you start to use S3.